Tonight is such a beautiful night. There's a full moon out and I can see so many stars. Whoa, look over there. It's the Big Dipper. And on the other side is the Milky Way. Actually, if you think about it, I can see these matters in the night sky every night. However, because the sky is very clear tonight, it makes my job much easier. My name is Telescope, and I would love to share the details about myself, about how I work. My buddies and I are devices that are used to magnify distant objects. Without the lenses inside of me, you would not be able to see so far into outer space. Optical telescopes can be classified by two primary designs: reflecting telescopes and refracting telescopes. Reflecting telescopes use a combination of mirrors that reflect light from an image. However, I am a refracting telescope. We focus the light and make distant objects appear brighter, clearer, and magnified. My earliest ancestors, as well as my amateur friends, use lenses to gather more light than the human eye can collect on its own. We usually consist of two convex lenses, the objective lens, which is the larger one, and the eyepiece lens, which is used for viewing. My objective lens collects light and bends the image to a focus, which is incoming light that is bent into a point. Then my eyepiece takes the bright light from the focus of the objective lens and spreads it to the size of your pupil. When Galileo came around, he gave my history an update, and he decided to build his own design of the telescope. Galileo built me using a convex objective lens with a concave eyepiece lens. My new name became the Galileoscope. With this new lens inside of me, I could magnify things 3 times more and later 30 times more. As a small 6-inch scope, I can do fascinating things like read the writing on dimes from 150 feet away. I do, however, have a couple limitations. Usually any type of lens creates a type of image distortion known as chromatic aberration. This occurs because as light passes through a lens, different colors are bent at different angles and they are brought to a focus at different points. Therefore, when you look at stars using someone like me, they appear to be surrounded by rainbow-colored halos. In order to correct this, one can put a thin lens of a different kind of glass behind my objective lens. An additional limitation is that large lenses are difficult to make completely free of defects. Glass also absorbs most ultraviolet light, making the visible light dimmer as it passes through a lens. Another one of my problems is that my lenses can sag and distort under their own weight, affecting the image quality and clarity. Despite all of my issues, I'm an amazing tool to use for expanding images that are too far away for people to see.